A typical medical clinic, an accounting firm, or local law office generates a continuous stream of sensitive data. Staff process intake forms, scan supplier invoices, and log confidential client communications throughout the workday. In the default modern workflow, the moment a document is scanned or an appointment is scheduled, that data is pushed toward the cloud. It is processed by remote servers and stored in multi-tenant databases owned by third parties. This creates a privacy paradox. Local businesses require the processing efficiency of modern AI to handle their administrative load, but they are legally and ethically barred from uploading raw client financials or patient records to external servers. Standard cloud architecture relies on constant outbound network requests. This dependency introduces latency and expands the network's attack surface, creating a liability for businesses governed by strict privacy frameworks like HIPAA. Enterprise vendors market their cloud tools as secure environments. However, a vendor's privacy policy is merely a legal promise regarding data they already possess. It does not change the physical path that data must travel to reach them. A completely localized, closed-loop network provides the only mathematically secure alternative. In this model, the physical processing hardware and the sensitive data it interacts with reside in the same room. Achieving data sovereignty requires severing the outbound connection entirely. Isolation must be enforced by the physical hardware rather than a digital policy. The direticular Main Street Commerce Bundle provides the architectural countermeasure to this cloud dependency. This hybrid system fuses physical routing hardware with containerized AI to ensure data isolation. By tying the software to the local physical network layer, the architecture prevents data from leaving the building. This setup creates a specific operational state, island mode. Island mode functions as a physical compute environment natively configured to drop all outbound requests. This makes the local network actively hostile to data exfiltration attempts. To understand how zero external exfiltration is practically guaranteed, we must examine the construction of the node from the physical hardware up to the software layer. The deployment begins with the physical footprint of the office, centering on the hardware that will act as the network's gatekeeper. The foundational Nomad Meshpoint router operates on an ARM processor with a PoE Plus port. A shielded Cat6 cable links the Meshpoint directly to a local Sovereign Sentry server, providing the storage and RAM needed for AI processing. Once active, this hardware establishes a localized Wi-Fi 6E canopy over the business. The Meshpoint immediately assumes control of the environment by managing local DNS. It explicitly routes internal administrative traffic to a private address, executive.local. Without physical ownership of the routing choke point, localized software privacy controls are easily bypassed. The physical router must define the network boundaries. Once the hardware is installed, the system initiates the digital provisioning process. Because this node peers with a decentralized municipal mesh, the network must verify that it only allows connections from trusted, authenticated local nodes. The system components are provisioned through a dual-point cryptographic authentication process. A unique SHA-256 hash and X.509 mesh certificate are retrieved from the private registry to verify the node. This permits the deployment of the OpenClaw Office Image, an administrative AI container that operates directly on the local host machine within the network boundary. Cryptographic provisioning ensures the localized AI operates strictly within a verifiable environment, inaccessible to unauthorized external devices. With the container active, the business can utilize high-volume document processing through the Archivist module. This module organizes physical records into a digital architecture. A mechanic scans 30 invoices, and the system sorts them without data leaving the server. Raw PDFs route through the Tesseract OCR engine. The software reads text and extracts the vendor name, date, and total amount without an internet connection. The files are then automatically renamed and logged into a local Postgres database. Processing these files locally creates a storage challenge, as thousands of high-resolution document scans can quickly saturate local NVMe drives. To manage this, the system uses an automated mitigation protocol. The Archivist triggers a Ghostscript compression algorithm immediately after processing to minimize the storage footprint. Native storage management allows an air-gapped system to run perpetually without external cloud storage providers. Beyond documents, the system processes confidential audio through the Scribe module. For example, a lawyer can leave a confidential voice note via a secure local signal channel. The localized Whisper AI engine converts audio to text entirely on device, removing the need for external voice APIs. A local large language model parses the transcription to extract the user's intent and updates the local CRM automatically. Processing intent natively on the hardware eliminates the network transit layer, removing a major vector for accidental data breaches. The operational scope of the node extends from the single office to a broader municipal mesh. During regional ISP outages that sever all standard external communications, the system instantly activates localized peer-to-peer survival networks. A mesh routing daemon on the router connects to neighboring direticular nodes. This allows the office to route local VoIP and data traffic, even when the primary internet provider is offline. Concrete architecture can sometimes block these high-speed Wi-Fi mesh signals between buildings. If the signal drops, the node executes an automated failover. It downshifts to the LoRaWAN protocol, ensuring critical updates still transmit. True edge compute requires building automated downshift resilience into the transmission layer to survive environmental failures. The final defensive layer of the island mode architecture focuses on preventing internal errors. This mitigates the risk of SaaS creep, where an employee might attempt to link the secure local CRM to a cloud-based marketing tool. An egress firewall built into the mesh node actively drops all outbound traffic destined for known data brokers, preventing the unauthorized connection. Absolute sovereignty depends on structural data retention. The hardware prevents internal data from escaping, even if a user attempts a manual cloud upload. When these layers are combined, the localized node functions seamlessly within the municipal mesh while remaining decoupled from the wider internet. The result is an autonomous digital ecosystem that operates independently of external infrastructure, ensuring your internal tools and local communications stay perfectly online. True operational privacy requires physical possession of the hardware rather than a service agreement with a cloud provider. By mathematically fusing hardware routing with containerized AI, the Main Street Commerce Bundle renders the local office an impenetrable digital island.